Okay, let me switch to live chat. Yeah, I wanted to remove this. That's one thing. And I have a push intrusive pointer to intrusive pointer. Oh. Oh, this one. So I want to, or I need to make item, which is a base class of several, well, other things that are derived from item, thread safe. And I do that by using my Git submodule thread safe, meaning I have to wrap stuff into another class that adds a mutex to it, which then must be logged before we can access it. But item is a base class, so this is a base class pointer, yet I want this to be unlocked. So in the last 2 days I fixed my thread safe library to allow a base class pointer. Like that. However, that it will only work if item is derived from AI ref count, because it needs a reference count now, and I don't think it is. So required AI ref count. And then the stuff that is derived from item then must of course be allocated on the heap and also stored in boost intrusive pointers. Well, that's going to be a huge change, I think. Let's try to find that. Grab some public item. Okay, we have an edge item, a graph item, and a node item. And a table node item. Okay, no, I'm not sure anymore. This item here is a dot item. I think I did the wrong item here. Wait a minute, what did I just change? Yeah, see, I changed item.h. That's nonsense. Dot item is the one, and that is already derived from AI ref count. I have no idea why, but okay, great. We think if now well, all of these are dot items then, and this one is something else. That's the item in the CPP graph is namespace. Yeah, this is not that easy. Let me think. Probably should search from this direction. The shared item pointers was changed. The type was changed. This should work. I mean, I can still pass it as a pointer. And then actually storing it here will increase the reference count. You can create an intrusive pointer from a pointer. What changed? No, it's not good, of course. I have to, this must be unlocked as well, I think. Yeah. So dereferencing the intrusive pointer gives me, again, just an unlocked item, unlocked base. So it just item, the type item is changed into a thread safe unlocked base item. But here something else happens. Now it's no longer an item, it's an attribute list, and I need the thing to be unlocked. Excuse me, I need it to be locked before I can access the attribute list. So I think I have to remove this one and instead get that one and then lock it in order to get the attribute list. Hello, interesting facts. Well, if it's a short question, but or a super interesting project. Is there a reason that I cannot just call attribute list directly on the unlocked item? It's not like const item pointer is a friend and the attribute list is protected or something, right? So you have to jump now to item. This is dot still. So I want to go to item dot item, and then we have a attribute list is part of item ID. An attribute list is simply public. So yeah, no problem there. I guess I should comment this one out. Can no longer do it. Do I call item, then I have this unlocked base. Yeah. And then I need to construct a red type from that. And the red type is then the type of this. And then that is then gives me a pointer to the item, a const pointer to item. So then I can call item list. So it become a lot longer, but yeah. Maybe sometimes I have to put type name in front of it. Let me use braces to make really clear that this is the construction of some type and not a function call. No, then we do not have this either anymore. Attribute list. I mean, this is using that thing, so yes, we don't have that. Clearly, we also don't have that anymore then. This gives us the non-const reference access to the thing, and then just using item and using that one. So the same fix me comes here. And now we need to get the right access. So the non-const access, and then you get the non-const attribute list. And here the return type also has to be changed. This is no longer an item, it is a thread safe unlocked base item. Yeah, it goes on and on, doesn't it? Strange. This is item pointer, and it has a public item const and item. This is derived from item pointer. Oh, the reason, yeah, okay. The reason is that we do a cast. So already have access to the item, but this is just a convenience thing that casts ourselves back to a T. That's interesting. Oh, little Greek, I'm not eating. So what type do I want here? The return type. I think it's still unlocked, right? I mean, let's keep it unlocked as long as we can. That depends on which project you mean, SL. Do you mean the project that I finished yesterday that I needed for this? Or do you mean this project? Or do you mean the project that I need this project for in order to write it? Which in itself is probably a project that I need for another project. You know how it goes. You're working on a project and then you need something, therefore you start a new project, and that's several deep. It's never finished, right? No, but this very project, which is a graph, CPP graph viz, I'd rather not think about it. I mean, it should have been finished yesterday, but I don't have time for it. It's taking way longer than I anticipated. But yeah, I never stop. So no, I don't know what I do. If it's gonna take another year, that would be absolutely unacceptable. And if I knew that in advance, I would stop right here. So hopefully within a year, but I don't know. I mean, if it is finished in 1 month, that would be brilliant. That would be really, really nice. And it's theoretical possibility, although I doubt it. And then I go back to the Vulkan engine. Anyway, it's going to take way longer if I have to answer questions. So let me concentrate on this. What do I want to return? I want to return an unlocked something. I'm not 100% sure that T here is the most derived class. Actually, I am, because I'm allocating it here with new. Alright, did I change the... No, I didn't. Let's go back here. I did change this constructor. What the hell? So I wrote this unlocked base yesterday, finished it yesterday anyway, and I'm still not, absolutely not used to it, of course. Now I'm wondering if I should treat it like a type that is wrapped inside an intrusive pointer, or if you ignore that, this is like a pointer itself. It's like a base class pointer. And I believe that I can just make a copy I can just make a copy of the unlocked base, which is really weird actually. Let's jump to that thing that I made. So it doesn't even have a copy constructor defined. If I would make a copy of this thing, then what it does is it's just another pointer. It's just a pointer to a base class. Let's ignore this, but it's also a reference, so that doesn't matter. And it is a reference to a mutex. So if you make a copy, you just have another pointer and another reference. Doesn't do anything. Doesn't even increment the reference count. So if I add an unlocked base to a boost intrusive pointer, this function is being called. But that just increments a reference count of the object that it points to. So the base pointer is being used, not the reference count to this object itself, which also exists. And well, I'm confused. Did I design this wrong or what? Yeah, I think I'm not. It looks the boost intrusive pointer wrapped around an unlocked base looks like a reference count to the unlocked base, but it isn't. The unlocked base really has to be used by value for every shared pointer. So I don't think this. It's not documented at all. Yeah, it's pretty complicated. Let me try to begin with adding a comment here. Not even being sure about a comment, but I think this is how I designed it or want it to work. What am I doing? Why am I not seeing this? I think I made a mistake because it doesn't add up. Now it feels like I need 2 reference counts, which is there. Let's go back to the drawing board. I'm going back to thread save test suite. Yeah, you see the unlocked B, which is unlocked base, is allocated on the heap. I don't think it's freed. This is leaking. That is wrong, isn't it? But that's the unlocked B itself. And here I have a new unlocked A. How does that work? That probably doesn't leak. But it might be pretty damn handy if I just had some debug output here for when the constructors of unlocked etc. are called, which I don't. Now, I did not write my tracker stuff for nothing, and this is a pretty complex. Can I not just use a utility that I already have to track instances of this class, so I don't have to do all the manual debug output myself? Because I forgot how it was called. So something with tracker, but that doesn't light up, or is not syntax highlighted, so it was not the right thing. I guess I put my tracker in, yeah, either utils or instance tracker. So we have a utils instance tracker. I want to use this one. How does that work? No explanation how to use it. You gotta be kidding me. What the hell, man? Okay, probably that is then used by something else that is documented. Object tracker, maybe. Nope, that's what I recently added. Now then, maybe it is in CWDS after all. Tracked. Can also track intrusive pointers apparently, separately. Track an existing class. Well, I started to uses declare tracked B, after which using B will print debugger info about construction, destruction, copying, moving, assignment, allocation, delete, blah blah blah. One may use track mute and track unmute to verbosely turn DC tracked on and off. To track an existing class foo, derive it from tracked. And add all this stuff. And add that to print the instance name of an object. One could write static cast foo tracker cons reference this to an OC. I don't think it's very clear. Plus, it totally does not explain how to track templates. This is just a class. What is foo? What if foo is a template? Difficult. I don't know. I don't have the feeling that this is very suitable for tracking template, so maybe I should redo it. Make that better. Oh well, yeah, what to do? I think I'm going to try to use this anyway. Yes, ideally I should have one per template signature thing. Can we not do that? The beauty of which is then I don't need a .cxx file, because it is a template, haha. think unlocked was already declared at this point or not? I think I did that. Yeah, here. I'm pretty sure it's wrong, but yeah, okay. Well, TSARB. Oops. Don't tell me that's the first time I used it. Demangle. What nonsense is this? Did I switch top? Yeah. Maybe you should move this into CWDS. It's more like a debug thing. Statically get the demangled name of any template parameter. But on the other hand, I already have that in my libcwd library. Maybe we should just use that. That should work as well. No, we don't know anymore where we were editing stuff. Penalty not there. Damn it. Let me get that. I believe you need to include a header for this to work. This header. Correct. So if you put a static inside a templates clause, then you get a static for a different static variable for each type. So this signature combination here. Say forget the rest, just talk about t. If the type t is different, so you have t an int and t a double, then you get two of those, one for each t, or the whole combination does. So I'm using that now, so that for some unlocked, depending on the template parameters, we get a different name. And the name is literally the demangled name of this type. So it just prints exactly that, but then the policy, etc. is just printed. So you get to see the unlocked, and you get to see the t and the policy mutex. And that's now a static variable, so there's a unique address. And that address is then used, here we take the address. The address is then used as a template parameter for tracked. So then we have different tracked instances that are unique per combination of the whole type that we're talking about, including the template parameters. And now we need to do that one. There's a missing thing here. No, wait. Pointed to that, so like that. Still need to add a header for tracked, I think. CWDS. And then it says that we have to add all these things, but it's only necessary, I guess, when they are already existing. So for each existing function here, We have to call that. Okay, this is orig. And I don't think we have specified any of those. But they are pretty default, right? It's just a base class being passed. Yeah, I don't think we need to do that at all here. Oh, here is a very fancy constructor, but it doesn't have an original. So this would just the default construct that base class, and that should work, I guess. The destructor is also not special. I think that works. If it compiles anyway. Let's see how terribly wrong this goes. Wow, actually hit in one. Amazing. Okay, so it said that it's going to print to DC tracked, so we better have that on. .libcwdrc tracked. I have no tracked at all, not even commented out. Is it not tracker? Did I look wrong? It says tracked here. It is that tracked. No, strange. Right, so now if I run this, I want to get some tracked output, right, just for unlocked. So that works. It tells me that new is being called for thread save unlocked, passing A and this policy, and two things, line and block size. And then here we see, I think, the same type. That's the name. The 0 means, well, just a random number to make a difference between one and the other instance. So this is the construction of instance number 0. And then we do stuff, and then here we see the destruction of instance 0. And then we do a delete of that thing. So first you destruct it and then you delete it. So that looks exactly like we want it. It's just being allocated, constructed, destructed and deallocated. But, well, like I said, I was expecting the unlocked base to be leaking. So we have to still add that as well. So I have to do the more or less the same thing, right? Maybe we should just copy it. Yeah, copy this. Put that in front of the unlocked. and then fix it. This is unlock base name. And the template parameters are now base and policy mutex. Base and policy mutex. Yeah, that looks correct. Three. I guess I don't need this underscore and whatever comes after it, because the name is already part of the something that includes unlocked base. You can just call this name. Oh, it's a bit double. Okay, and then go back to unlock base. Or not. Can also look here. Just need this one. Now this is an unlocked one. Oh, it's unlocked. Never mind. Thought it was an unlocked base. This is an unlocked base. So here we have an sort of a copy constructor. It's not really a copy constructor maybe, but what is this? Yeah, that's difficult. Is this a copy constructor or not? What should I pass to the tracker base class? Looks like a copy constructor. Unlocked base pointer is this thing. So that is the base pointer. I could have used unlocked base m pointer, m base. I mean, and mutex is a reference. Yeah, if you ask me, that's also the same thing as a copy constructor. The only reason that's not really a copy constructor is because there is no cons in front of this. Is that because, well, if there was a cons in front of it, I would get a const pointer. If I call pointer, so yeah, that's dubious. Have a look at the mutex. The mutex is of the reference type of the policy mutex. For example, this one, so you get primitive ref. Sure. Now, I must say, it looks very much like a copy constructor. So I think I should pass that. 3YY. Yeah, sure. Dubious. Yeah. What does that? Too few template arguments for template name unlocked. Name unlocked base. Got that one. Okay, so yeah, I'm calling new on an unlocked base, which is then default constructed. It even tells me. Brilliant. It leaked. Yeah. Yes. Yeah, I'm glad my utility works. So that's kind of problematic. You forget about the intruder pointer for a moment. Then I have an unlocked A. I can create an unlocked B from the unlocked A. which I then can use like that, which is what I want. Pretty sure of that. But it's not really a pointer. I mean, it's a wrapper around a pointer and a reference. But the pointer and the reference together need allocation or size. They have a size. It's an object by itself, even though it represents a pointer to that thing, or rather to that thing, but then in an unlocked way. Can you even make a copy of unlocked? What happens if I make a copy of unlocked? I suppose that should work. I just make a copy of A. Yeah, that should work. I mean, the thing is, you should see this as A. It's just A. That's what it is. I can make a copy of A. The only thing is that I cannot access it. So if I make a copy of A, I also have to make a copy of the mutex. Not a copy of the mutex, but a new mutex, but of the same type. And it's a new A with its own mutex, and it just plays its own life then after that. No problem. This thing represents a pointer to B. Sorry, pointer to A. Or pointer to B actually, but then pointer to the base class of A. You can construct it from an unlocked, and then we have something that you can see like a pointer to a base class of A. And if you make a copy of this, then you don't need a new mutex. You do not need a new mutex. In fact, at the moment you create it, you don't even get a new mutex. It just uses the mutex of this thing. It points to this thing. This thing better lives longer than that one. It's just a demand that the programmer has to take care of. And if I make a copy of this, I don't duplicate anything. I do duplicate the unlocked, but I'm not duplicating the A or the mutex. So the unlocked B in itself can be viewed as a B pointer. except that you don't have access to it until you unlock it first. Until you lock it first. You'll have to lock the mutex. You would lock the mutex that is included in this unlocked A, and then you can access it through the base class. So this is a protected A. This is a protected B pointer. It says B here, but actually it should be B pointer, because that's what you get back when you unlock it. As it were. I mean, it's a wrapper around it as well. I don't know. Okay, now an intrusive pointer. Now making an intrusive pointer of that thing that it should be looked at as if it is a base class pointer. Now at first sight you would say, okay, this means, intrusive pointer means that it is a pointer to this type. But then when you have a pointer to a pointer, looks like I need a double reference count. I have a reference count here, and I need another reference count for the unlock B. So that is, say here we leave the scope of this intrusive pointer, therefore this unlock B is being destructed. That's what should happen when we leave the scope here. Something is wrong. Horribly wrong. Unlocked itself. Yeah, this intrusive pointer add. The unlocked itself doesn't even have a reference count either. I wanted to abuse the reference count of the object, so A or T here, but I would still have to delete the unlocked wrapper, right? Not the A itself, which isn't even allocated. Or is that what I'm doing here? Oh, that's what I'm doing here. So you get an unlocked pointer, and then I abuse the reference count of the underlying T, and if that reaches 0, this returns the previous value. So if it decrements the reference count, if the previous value was 1, then now it is 0, and then I delete the unlocked, which then also deletes the T because the T is embedded inside the unlocked. So that looks correct, and well, adding is just adding, so it's the same thing that I'm decrementing here is being incremented here. It's kind of strange also to use intrusive pointer add here and then allow deletion there, which is ridiculous, but yeah, well, it works. Maybe I should use, I mean, I can't use the intrusive pointer release here because that would immediately destruct this pointer. I don't want that to pass through here, then it doesn't delete that pointer. It just returns the previous value, and then I can delete the correct pointer. But now we have an out of balance API. Let's call inhibit deletion. Take the allow deletion. Here I have an inhibit deletion. And that would be better. What the hell is this? Can cause immediate allow deletion. Cause? What do you mean? So if I pass false, then we better be sure that the previous count is always larger than 0. Well, that's simply not true. So I guess I have to pass through here as well. Previous count could be 0. It's the first time we call that. I have to make this false in order to stop the cert from firing. By default it is true. Can I read this? Because mcount is overridden with s deleted upon destruction, and CWDebug is defined, a reference count of 0 means that this object is probably still being constructed and wasn't passed to a boost intrusive pointer yet. Oh, right. Yeah, totally. If under those circumstances an intrusive pointer add ref / intrusive pointer release pair that is merely intended to temporarily inhibit deletion could inadvertently delete the object while it is being constructed. Ah, okay, I get it. So the immediate allow deletion means that if you call inhibit deletion and you know that the allow deletion might happen immediately after this call to inhibit deletion, even before the construction has finished, then you must pass false here. Sorry, then you must pass true here. So confusing. So yeah, in this case, the immediate allow deletion cannot happen because we're going to finish the construction before we destruct it. So I can pass false. Okay, so I can pass false to this function, and at least it looks a little bit more in balance. So I think I'm going to do that. Okay, and then the unlock base here. This increments, and now suddenly I do use intrusive pointer add ref. Because it doesn't really matter what I do, but yeah, so anyway, the same reference count as here is being incremented. So it's like, this is even more like an inhibit deletion, I would say, than the other one. This is just more like, yeah, intended to stop a call to that one from deleting the unlocked. While we are not even an unlocked, we are an unlocked base. So I think it would be better to use inhibit deletion here as well. And in this case, should I use false as well? I think I shouldn't actually. Yeah, we should only get here when we already got here. So the count is already non-zero. It's kind of impossible to get here without having an unlocked. So I think this is just a really normal inhibit deletion. Stop a destruction of a boost intrusive pointer unlocked from destroying the unlocked that we are pointing into. And then again, we have a better balance here. So inhibit deletion, and then here we can call allow deletion. And then the same thing holds. Exactly that. Now, actually, maybe not. But this kind of says I don't want the destruction of this object to result in the deletion of the unlocked. But why not? Why not? The reason is because I don't have the pointer to it. I can't delete it at this point. Or can I? No, I cannot. That's highly annoying. That is highly annoying. I would like to destroy the unlocked, but I don't have a pointer to the unlocked at this point. Okay, so this is just a balanced inhibit deletion and allow deletion. Then you wonder, why would I pass through here? Because it has to be larger than 1 anyway. Okay, suppose that the assert would fail, then what this would do is destroy the wrong thing, and then maybe crash before we get to the actual assert. So I would rather assert than crash before that, because assuming, yeah, well, the real error is then that the assert failed. So if the assert does not fail, then it would have worked if you passed false here, but passing false is wrong because you never ever want to delete this pointer. in the first place. We would have to pass. Yeah, this is the base class pointer. It's just nonsense. However, now what is missing is that I need a second reference count that counts the unlock base object itself, it seems to me, right? I'm just not happy with having to allocate unlock base on the heap, I must say. Isn't it more like I should not wrap this thing at all in a boost intrusive pointer? I could just use I could just do the inhibit in the constructor of the unlock base, and this in the destructor. Why would I even need an intrusive pointer? Maybe that's the problem. Yeah, the whole incrementing here doesn't seem to make any sense, really. I think I should move this to the constructor and the destructor of the unlocked base. What am I doing? It's not a destructor. I wanted to add this to a destructor. Right. I think this should compile. Let me test it. It's not a template. Yeah, and I think I just don't need or even want the unlocked base to ever be added to a boost intrusive pointer. I mean, it's the reference count that I care about is already incremented if I just created those objects. They are already pointers. It's a bit mind-boggling to think about this, but I believe that we can just get rid of all of this. Don't need that, which means I need to delete a lot of code. That's unlocked. So this is, what is this? The friend of the functions that I just deleted. Unlocked? No, this is still unlocked. What class am I in now? Unlocked, sorry. You have to go to. This is the for declaration of the function that I just deleted. And I think I don't need that either anymore. Not sure though, but that's just deleted. And then here we have the friend declaration of those things. No longer exists. And that's unlocked itself. Fortunately, the tracker needs it. And then of course you get a problem here because I am putting my unlocked in an intrusive pointer, which we will now no longer do. I just have an unlocked B, and I should be able to just assign that from a dereferenced A. And then of course here as well, that is just an unlocked B. It could be either by value or by reference. I'm going to use it by value for a start. Mail. PP. You cannot dereference it because it's no longer a boost intrusive pointer. Isn't it beautiful? It works, and it prints that we allocate unlocked, we default construct unlocked, we construct A, we default construct an unlocked, this creates a copy. We're calling F here, I think. It says leaving scope and then it calls F. Oh yeah, calling F causes now yeah, to make a copy. So this is the copy constructor, because well, you see that is being passed null. So you create instance 0, and when then we pass that to the copy constructor, creating instance 1, and then we leave F, destroying instance 1. Leaving the scope, destroying instance 0, leaving main, destroying instance 0 of unlocked. Destructing, I mean, and then destructing A and then deleting it. Very good. No, and then if we just pass it by reference or const reference, I think that should work equally well. Let's try const reference, why not? Yeah, I actually had a feeling that maybe that wouldn't work. Let's try passing it by reference. Yeah, that's correct. If you pass a const reference to an I'll say wrapped thing, then you can only get the read access from it. Only a C-read even. So this should compile and still work. And now of course we don't create an instance 1, just instance 0 and then destruct that where. And if I pass a const reference here, then that should not compile. It should not even compile if I comment out this one, because you can also not create a read. But we can create a C-read, because a read can be converted to a WAD, so that's almost the same thing. But this should still work. Brilliant. I'm totally happy with this now. And yeah, passing by value, I don't know. Could do that. Could also not do it. Let's commit this as being a working state. And then I have to go make dinner, I think. Get diff, get status. Now let's do the get submodule first. Yeah, before I commit this, I'm gonna turn off tracking. And actually I have to still test if that even compiles. It's just the tracker stuff. This was removed. More tracker stuff. Also removed. And this was then added because we do it now in the constructor and the destructor. Yeah, looks good. Let's add a comment to this new define. Set this to 1 to print tracking information about locked, unlocked, unlocked and unlocked base to DC tracked. Oops, not really. I think it's finished now, so. push it. And then we go back here. Update it. Ooh, that get merge only failed. What is that? Oh, I made local changes. It's not working. CD thread save. Yeah, this is a nonsense then, right? Git restore. Oh yeah, but no, the boost intrusive pointer must be deleted, but I want to see a compile error. It makes me feel good to see an expected compile error before I fix it. Still too few. What it just passed it. Why does this even compile then? That. Not true. Okay. Yeah, no matching function for initialization of CPP graph is .const item pointer. Candidate constructor not viable. No known conversion from item pointer to thread save unlock base item pointer. It's not giving me the compile errors that I want, strangely enough. Uh, hmm. Yeah, it really has to be the same thing as a const item pointer. And it took away my music again. Sure. No permanent attribute lists. Maybe I should make this a type, also a type of this class, right? At the very least, I don't want to have to type that every time. I don't know. I don't know what to do. So let's just copy it and use it. That's the const one. So we do need. Oh boy, what was it? Is this a template? Nope. thread save unlock base item lock policy red item pointer item. See if this even compiles. Too many arguments provided to function like macro invocation. Excuse me, what are you talking about? Oh no, you've got to be kidding me there. The out entering is not using, well, it's using a comma. Yeah, it's kind of silly. Oh well. Not sure if this will do the trick. Not even sure if it will do the trick. $8.5. Uh-oh, still the same thing. Yeah, well, maybe I should do something like define that bloody type. Graph item, this is in dot. Then I jump to different directory. Now I'm back here. Shouldn't this be the one? Using oh boy. I don't understand why I'm having this small glass here. Why is this a thing that I have to add a new type to? Then what was I doing? Where is my boost intrusive pointer? I don't add it yet here. I don't get this. Yeah, it's dot graph. Ugh, really? Now there it is, item pointer. See, those are, oh right, yeah, and that includes item. I think I should move this to item then. Okay, this item, because it's included here. Which means this item, which means I'll put it here. Which means I need to include thread save here. Which I'm pretty sure already includes ARF count. Ja. No member name .id in thread save unlocked base. Probably even need it here, so I might as well start with taking the lock here, I think. Create a read lock. Item read locked. And then I can use that here. end here. This thing demands that we pass an item pointer. Items draw in place. Nope. I probably want to pass an unlocked item here. So instead of an item pointer, just item is already returning an unlocked thing. Yeah, I'm still going to put it outside that, I think. If def cw debug. And if, otherwise I have to repeat it twice. And we use it here and there. And the same thing holds for here. Ugly, ugly. And I suppose this is not going to compile. Yeah, I don't think I want to or need to pass a pointer anymore. Why is this thing taking a pointer anyway? So I'm adding it to items. What? It's storing a const item pointer. I wanted to see that there is a problem with using boost intrusive pointer here, because my unlocked base no longer supports that at all. Why am I not getting any errors about that? Very annoying. No, I'm not going to change it. But really, this is not there. Going to delete that. So this is just, this thing should in the end just be an unlocked base. So const item pointer is a wrapper around an unlocked base of item. So it is already unlocked. Const item pointer stores an unlocked something. What I want to add here is an unlocked thing. And that's the type that I get back from this call to item. Because item on an item pointer simply returns item pointer. Where's my item? Here's one item, so that returns an unlocked base of item. I really need to make this a type that it can access like everywhere. I called it an unlocked item type, right? So let's define that as well here. Now I had it about the push intrusive pointer. I just want this to be an unlocked item type. No, it's not a smart pointer anymore. Uh-oh. But it's an unlocked base, which is yeah, well, can hardly call it a smart pointer, but it is incrementing reference count. So yeah, in a sense, it still is. I'll add a comment, I guess. Let me read what the Sun said. Sun says, "Hey Broken, I ask you when the what? Can I ask you when exactly the time we should use pointer instead of reference?" Well, that's a good question. I use a pointer when it's not const, basically. So a reference is a pointer const. Let me see if you're still there. Do add ts. Yeah, he shows up, so he's still there. So if you have say a pointer const, then you must initialize it because it's const. You cannot not initialize it and initialize it later. Well, let turn be just an a, and then of course you must take the pointer to the a. Now if you do this, you must initialize it immediately. You cannot change it afterwards. So if you would initialize it with a null pointer, that wouldn't make any sense, because then it's just a null pointer and you cannot give it a different value later on. Plus you cannot give it a different value later on. It's a const. So that thing always points to the same thing. That is the same as a reference. So this is 100% the same as an a reference. Reference must be initialized. It does not make any sense when the reference is null pointer, and you cannot change it afterwards. So these two are exactly the same. But if you would do a pointer, you don't have to initialize it. You can initialize it later to something, and you can change your mind. You can later change it again. So I would use a reference when this works for you. But when you need to change the value, or you have to declare it at the moment you don't know the value yet and you want to assign it later on, then you need a pointer. You're welcome. Okay, what the hell would this be a pointer? It doesn't make any sense anymore. Could make it a reference, or can even do it by value. You know, our unlock base is pretty happy when you do it by value. And this is a const cast of still a bloody pointer. Okay, so we no longer want it to be a pointer, so this is now the same thing, but then just a reference instead of a pointer. So then this is no longer a pointer. It's kind of really difficult, this, but it is a pointer because the unlocked item type wraps a pointer, but then the wrapped pointer I pass by reference. And here we have a return type. Of a const unlocked item type, and that means that you cannot take the write lock on it. So it is unlocked, and if you lock it you have to take a const read access type, and that cannot be converted to a write access type, so you can never write to it. It's just really just const access, hence the const here. And my shared item pointer is no longer a boost intrusive pointer, so obviously that store has to be deleted as well. I just return now a const reference to this thing here. And here we have the same thing. I want to use now that thing, but then by reference, and now it's not const. And this one creates a new one. Creates a new T. So I'll have to change that as well. Oh shit. This is going to run in that assert. I would like to just, I mean, I need to create a T, but a wrapped T, no? Man, this is so difficult. The only reason that this is going to work is because it's such a robust library. Type safe, it's aka it's not going to compile. Until it compiles it, then it will work. Ha ha ha. Can only hope. Const cast is pretty damn evil. You really have to know what you're doing before using that. You should use const a lot more, man. Maybe this will help because it's also on topic what you just asked, I think. Where's my... yes, I'm going to refer you to something that I wrote myself. Yeah, this one. You got to read that turn. Concentrate it until you understand it, and then maybe from that moment on you can start using const. I should go, yeah, make dinner. It's 7:30 now. I'm in the middle of something, but well, I lost my overview a while ago anyway. It's really big mess, this. I'm going to make dinner, okay? So I'll be back later maybe. And otherwise